Hello students, this video is about solving quadratic inequalities. So that's different than just graphing them, but we're trying to solve them now. So let's look at one example. So if I have x squared plus 2x minus 8 is less than 0, and I want to solve that inequality, that is different than just graphing the graph of that and shading, okay? So, but I can solve it by graphing. So what I'm going to do is I'm going to set it as an equality. So I'll do x squared plus 2x minus 8 equals 0. So if I were trying to graph the equality of this inequality, and then I'll deal with the inequality piece of it, I can factor that. So that's going to be x plus 4 and x minus 2 equals 0. So my roots are at -4 and 2. So I'm going to put that over here on my graph. There's my 2, and there's 1, 2, 3. There's my -4, okay? And honestly, it doesn't matter where your vertex is right now. We're just estimating a graph. That's fine. The main thing is I know because A is a positive value, it's +1, that it opens up, and that's really all I care about right now. So the graph looks something like that. I mean, it's not exactly that, but it doesn't matter. It's close enough, and that's all that matters right now. So now I want to think about, let's go back to our inequality up here, okay? I want to have the x squared plus 2x minus 8 less than 0. If I look at the graph, where is the graph below 0? I'm hoping that you notice it's down here. That's where the graph is below 0. So my initial assumption then for the solution to this is that x, its solutions, are between -4 and 2. And I could write it in interval notation like this as the solutions. And it can't include -4 and 2 because x is actually 0 there. It would include it if my original had an equal sign, but it doesn't. Now I want to test and make sure that my assumption is correct. So I can put in a test point. So I'm going to test over to the left of the -4 in this region. So I'll test -5. And I do -5 squared plus 2 times -5 minus 8 less than 0. And see if that's a true statement. So that's going to give me 25 minus 10 minus 8. And is that less than 0? No, not true. Now I'm going to choose a section from the middle, the part that I think is correct. So I'll pick 0 because that's always easy, right? So it gives me 0 squared plus 0 minus 8 less than 0. That's true. So right now that part that I've done in red is correct. And then finally, I'll test something out to the left, or I'm sorry, to the right. So let's see, I'll pick 3, and that'll give me 3 squared plus 6 minus 8 less than 0. So that's 15 minus 8 less than 0. 7 is not less than 0, so that's not a solution. So my solution is confirmed, and the solution is the interval -4 to 2. So when x is between -4 and 2, that's the solution to this inequality. Okay, next let's do one where it's greater than or equal to 0. So in this case I have 2x squared plus 4x minus 5 is greater than or equal to 0. And the first thing I'll do is I'll make the same function, but as the inequalities in a function. Same equation or inequality, but as its function or equation there. Okay, so we turn the inequality into an equation. This one's not factorable, so I'm actually going to use the quadratic formula. So I get x equals -4 plus or minus the square root of, let's see, 16 plus 40, so that's going to be 56 divided by 4. Okay? So if I keep working on this, I'll get x equals -4 plus or minus. This is going to have, it's factorable by 4. I know that. 4 goes into it 19 times. So it's going to be 2 root 19 divided by 4. So that's going to give me x equals -1 plus or minus 1/2 root 19. okay? So those are my two roots, which doesn't really help me with graphing. It's approximately 0.87 and negative 2.87, just so I know where to put it on the graph. So it's going to be about here and here. And again, it opens up. It doesn't really matter where my vertex is. I'm just going to draw the graph. So it's something like that. It's not perfect, but it's an estimate. Okay? So now from here, I have to think, okay, where is the graph actually going to be greater than or equal to 0? Well, that's this part of the graph. And because it's equal, it includes the roots. So my estimate of my solution would be, it's going to be from negative infinity to negative 1 minus root 19 over 2. And then the union of that with negative 1 plus root 19 over 2. I think that's what it's going to be. But I could also do test points to make sure I'm right. So let's try testing the 0, 0 point. So if I test at 0, 0, I get 0 plus 0 minus 5 is greater than or equal to 0. Well, negative 5 is not greater than 0, so that doesn't work. Okay? Oh, let me come back to my original hypothesis. This should be a bracket because of the equality. Oh, this is wrong here. Sorry. This should be to infinity. And so this is a bracket. That has to go on to infinity. That's just the point to infinity. Okay? And I can test points to the left. I could test something out here, and I can test something out here to make sure that it's actually right and that those are either greater than or equal to 0. They will be, and this is my solution. Okay? So as you're doing these, we're going to start with you're going to graph them, and then based on the graph, determine what appears to be the right part for the inequality, and then we're going to write it in interval notation. We'll continue going over it in class, but hopefully this will help you with just a couple practice problems to see how it goes.